This lesson is reviewing properties of exponents. So to start out with some vocab, this entire expression, x to the fifth power, is called a power. And there's two parts to the power. There's the base, which I'm going to highlight in yellow, and then there is the exponent, which I'm going to highlight in blue. So the first property is the product of powers property. This means we would have a base a raised to some exponent, in this case m, and if we multiply it by another power with the same base a but a different exponent, the rule is that we keep that same base but we add the exponents. All right, so once again, this is called product because there's a multiplication symbol there, of powers because we have two powers multiplied together. Now, to show you an example with some numbers for the exponents, if I have x to the third times x to the fourth, we know x to the third power is x times itself 3 times, and x to the fourth power is x times itself 4 times. So you end up with x times itself how many times? 7. And how can we get that 7? By adding the 3 and the 4. So in words, when multiplying two powers with the same base, we add the exponents. We have 3 examples to practice this. Our first example is very similar to the one I just did above. If we have x to the third times x to the fifth, we would add 3 plus 5 and get x to the eighth. So we're multiplying two powers that have the same base. Make sure these bases are the same first, and then just add 3 and 5. Now here I have some numbers in front. They're called coefficients. So I would multiply those coefficients like normal. 6 times negative 3 is negative 18. Then with the powers, x to the second times x to the seventh, I'm adding the 2 and the 7 to get x to the ninth. So my final answer is negative 18, x to the 9. So just to kind of go back and look at this again, these coefficients get multiplied. It's only the exponents that get added. All right, so I would do the same thing here. I would multiply 2 times 3 times 4. That's 6 times 4, which is 24. But then with the x's, I'm going to add all those exponents. So I have a 2 plus, here I would just use a 1 because there's nothing there, plus a 3. So 2 plus 1 plus 3 adds to 6. All right, let's move on to our next property. We have power of a power property. So it's where you have a power and you raise it to another power. So it's kind of like you have two exponents. You have one inside the parenthesis and then one again after the parenthesis. So let's actually look at example 2a, and then we can go up and fill in the rule. If I look at this where I have x to the second power to the fifth power, well, I know if something is to the fifth power, I multiply it by itself 5 times. So I would have x squared times x squared times x squared times x squared times x squared. Now from the previous property, since all of these are multiplied and they have the same base, I would add all the exponents. So 2 plus 2 plus 2 plus 2 plus 2 is 10. Now a shortcut is, how else could I have gotten this exponent of 10 using a 2 and a 5? I would multiply those together. So now going back up and filling in the rule, a to the m to the n is equal to a to the m times n. And when raising a power to a power, we multiply the exponents. So from now on, I don't have to do all this extra work. I can just follow the rule. So in part B, if I'm taking a to the fifth, I have a to the 25th power because I multiply 5 times 5. Here, if I have c to the third to the fourth, I would have c to the 12th because I am multiplying 3 times 4. I'm going to, before we move on, I'm going to talk about some common errors. One error students might make on part C here is they get an answer of c to the 7th. Can you pause the video for a minute and think about what that student did wrong if this was their answer? All right, hopefully you had a minute to think about it. So if they got c to the 7th, it looks like they added instead of multiplying. So remember, you're adding if it was c to the 3rd times c to the 4th with two bases, both c, and then you would add the 3 and the 4. This is different. We're taking c to the 3rd raised to the 4th. Here's another common error I might expect to see. C to the 81 power. Can you pause the video for a minute again and think about what a student might have done if they got c to the 81? All right, what a student would have done here is they would have taken 3 to the 4th power. And 3 times 3 times 3 times 3 is 81. So that 3 to the 4th power is 81, but we aren't taking the 3 to the 4th power here because that 3 is an exponent and that 4 is also an exponent, and so we're just multiplying those. Now if I had a 3 in front with c to the 3rd all to the 4th power, then the 3 to the 4th would be an 81, and this would still be a 12. This would be 81 c to the 12. But here the 3 is not a base, it's an exponent. So if I had a base of 3 to the 4th, it is 81, but that 3 is not a base. So those are common errors, so try not to make those mistakes, and just remember that you simply multiply those exponents. All right, the next property. We have power of a product. So it's kind of like product of powers, but the wording is reversed, power of a product. So now you're taking a product, which is when you multiply two things together, and raising that product to a power. So it's kind of like you're almost distributing the exponent to each base. I have two parts to my base, a and b. If that entire thing is getting raised to the m power, a has to get raised to the m, and b has to get raised to the m as well. And since a and b were multiplied together, you still just keep a multiplication there. So to fill in words here, when raising a product to a power, you want to raise each base to that power. And that's actually where it says lead coefficients 2. That's actually what I had just done above, showing you that extra example there in pink. So if we look at example 3, we have a 7xy squared. So there's 3 parts to the base here. The 7 has to be squared, the x has to be squared, and the y has to be squared. And finally, I can simplify 7 squared to 49. So my final answer is 49, x squared, y squared. All right, on part B, I have a 2x squared cubed. So first we have two bases, the 2 in front, that coefficient, and then the x. So I'm going to separate 2 and then x squared. And then I'm going to put each of those in parentheses to the 3rd power. So when I take just 2 to the 3rd power, that's 2 times 2 times 2, which is 8. When I take x to the 2nd to the 3rd, this is a power to a power, which was our second property today. So that's where I multiply, so 2 times 3 would be a 6. Notice in our problem we had a 2 here and we had a 2 here. But we did different things with those 2's because one of them was a base and one of them was an exponent. So with the base, you just took that number to the 3rd power and got 8. With the exponent, you multiplied it with the other exponent. 2 times 3 gave us a 6. All right, finally, I have a negative 3x cubed y to the 5th squared. So I have to make sure that I square the negative 3, the x to the 3rd, and the y to the 5th. So I have 3 separate bases here. Now, if you want to show the work, here's kind of an optional step. You have your negative 3 squared, x cubed squared, y to the 5th squared. So a negative 3 squared is a positive 9, because you have a negative times a negative. 2 negatives cancel out. However, if that was to the 3rd power or 5th power, any odd number, then I would still have a negative in my answer. Okay, x to the 3rd to the 2nd is x to the 6th, because I multiply those exponents. Y to the 5th to the 2nd is y to the 10th, because I multiply those exponents. Don't put a 7, that mistake would be adding. Don't put a 25. That means you did 5 squared, but you want to multiply 5 times 2 because this is a power to a power. So there's our final answer. One more thing I didn't really talk about yet is just that when you're ever raising anything to the second power, you can call it squared. Anything to the third power, you can call it cubed. Or you could say x to the third power, x to the second power, but usually we say x squared and x cubed for those exponents. Everything else you can just say to the fourth power or fifth power and so on. All right, go ahead and pause the video and do the U try, A, B, and C. And when you're finished, then you can hit play and check your answers. All right, let's see how you did on part A. So on part A, there are no exponents outside the parentheses, so really all the parentheses are doing here is just telling us that we want to multiply these 5 expressions, or sorry, these 3 expressions, 1, 2, 3. We want to multiply them all together. So let's look at our numbers, our coefficients. We want to multiply 5 times 2, which is 10, times 3, which is 30. And then if we look at the x's next, which I'll highlight with pink, we want to multiply, and I'll highlight maybe the entire power, like this. We want to multiply x to the first times x to the second times x to the third. So when I add 1 plus 2 plus 3, that's x to the 6th power. And then finally I'm left with the y's. 2 plus 1 plus 4 is a 7. So my final answer is 30, x to the 6th, y to the 7th. On part B, first I'm going to take care of this piece of the expression that has the squared after the parentheses. So that becomes 4 squared, which is 16. A to the third to the second is a to the 6th because I multiply those. Now I want to multiply it by 2a to the 5th. So whether you use parentheses or just a dot in the middle, we want to multiply these together now. So there I did a product to a power. And then in the a to the third to the second, I did a power to a power. Now I'm just multiplying these together. So now 16 times 2 is 32. A to the 6th times a to the 5th is a to the 11th because now I'm adding. What you have to be careful about here is you're using multiple properties in one problem. So notice like these got multiplied because we had a power to a power. But then these got added because I'm just multiplying 2 powers with the same base. So make sure you just keep track of which property you're using. All right, last one. Let's look at this first piece where I have 3 to the third, which is 27. X to the second to the third is x to the 6th. Y to the third is y to the 9th. Then I'll multiply that by a 2x and an x to the 4th, y to the 3rd. So now if I just look at the numbers, 27 times 2 is 54. Then if I look at the x's, x to the 6 times x to the 1 times x to the 4 is x to the 11th. 6 plus 1 plus 4. Y to the 9 times y to the 3 is y to the 12th. 9 plus 3 is 12. So that should be your final answer on part C. All right, on the back, we're going to move on to a couple more properties, and these are division properties now. So we have a quotient of powers and a power of a quotient. Quotient of powers is similar to the very first one, product of powers. And then when we get to power of a quotient, that's similar to the third one on the front, power of a product. It's just product is being replaced with quotient. So on example 4a, I'm going to do the example first, then we'll fill in the rule. If we know a to the 10th power is a times itself 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a to the second is a times itself twice. If I cancel an a on top with an a on the bottom, I can do that twice here. And then I'm left with 1, 2, 3, 4, 5, 6, 7, 8 a's on top. How could I have gotten from the exponents of 10 and 2 to the 8? By subtracting them. Also, if you look back up at the first property, when we were multiplying 2 powers with the same base, we added the exponents. So now when I'm dividing 2 powers with the same base, I subtract the exponents. So in words, when dividing 2 powers with the same base, I can fill in the blank, subtract the exponents. And then in the box there, you should fill in a raised to the m minus n. So I don't need to do this work every time because now I know when I see a 10 and a 2 there, I just subtract to get 8. All right, now in part B, we actually have coefficients. So just like above, when those got multiplied like normal, these will just get divided like normal. Then when I look at the x's, I will subtract those exponents. So with 8 and 16, if I divide the top by 8 and the bottom by 8, this reduces to 1/2. So 1 on top, 2 on the bottom. Then x to the 5th over x to the 3rd. 5 minus 3 is a 2, so I have an x squared. So you don't need the 1 in front. Your final answer is x squared over 2. Just make sure that when you divide, you have that 2 on the bottom in the denominator. All right, here if I divide a negative 18 and a 3, I get a negative 6. If I divide x to the 9 by x to the 6, I get x to the 3rd because I'm subtracting those exponents. And finally with the y's, when I divide y to the 4th by y to the 3rd, I get y to the 1. 4 minus 3 is 1. And you don't need to put that 1 there. You can just leave it like this. Negative 6 x to the 3rd times y. All right, on the front page, when we talked here about power of a product, we took a product to a power and raised each base to that power. Well, same thing here with power of a quotient. We are going to raise each base to that power still. So I'm going to take a to the m divided by b to the m when I have a fraction a over b to the m. So we are raising a quotient to a power. We want to raise each base to that power. And this includes lead coefficients too. So here I have a base of x and a base of y. So the x has to be raised to the 6th in the numerator, and in the denominator the y is also raised to the 6th power. And that's it. Now in this next one, there's actually 4 bases. There's the 2, the x, the 5, and the y. So I have to take 2 to the 4th and x to the 4th, and in the denominator, 5 to the 4th and y to the 4th. Now this can be simplified since I have 2 to the 4th power and 5 to the 4th power. So when there's all numbers, then you should multiply that out, where with the variables, those just stay how they are. So 2 to the 4th power is a 16, x to the 4th. And 5 to the 4th power is 5 times 5 times 5 times 5. You can use a calculator for that. I know 5 times 5 is 25, and 25 times 25 is 625. And then y to the 4th. Now I did mention you can use a calculator, so let's talk about that real quick. If I want to type this into the calculator, one option is 5 times 5 times 5 times 5. But there's another option. There is, and it might depend on which calculator you have, but most calculators, it's a button that looks like this, a caret button, where you could type in your base and then the caret symbol and then the exponent. There's also some calculators where I think it might look something like this, where they show you a power with a base and an exponent, and you probably put the 5 first and then press that button and then press the 4. So depending on what kind of calculator you have, look at your calculator, try to find that exponent button, try it out, and do 5 to the 4th power. Make sure you get 625. Okay. Last one here, I have in the numerator a 2, an x, and a y that are all bases. Down here a 5, an x, and a y that are all bases. So there's 6 pieces to this problem that have to all be raised to the 3rd power. I would say this step is optional. You can start by taking your 2 to the 3rd, your x to the 4th to the 3rd, your y to the 3rd to the 3rd, and then on the bottom, 5 to the 3rd, x squared to the 3rd, and y to the 3rd. Then you can simplify this. So all 6 parts now do have to be simplified. 2 to the 3rd power is 2 times 2 times 2, which is 8. X to the 4th to the 3rd, now we're raising a power to a power where we multiply the exponents. So 4 times 3 is 12. With y to the 3rd, multiplying once again is y to the 9th. Then 5 to the 3rd is 5 times 5 times 5, which is 125. X squared to the third, you multiply the 2 times 3 to get 6, so x to the 6th. And then you just have y to the third here. Now, we're not done with the problem because we have the base of x twice, and then we also have the base of y twice. So I need to use my quotient property, where if I'm dividing powers with the same base, I subtract their exponents to finish this problem. 8 over 125 cannot be simplified, so we can leave those coefficients how they are. But if I divide x to the 12th by x to the 6th, I subtract 12 minus 6 and get 6. So I have x to the 6th power. And y to the 9th divided by y to the 3rd, I subtract 9 minus 3, which is a 6, so I get y to the 6th power. And there's my final answer. Before you try, let's talk about this problem another minute here. One other option is before we did everything to the 3rd power, you could have simplified this fraction first. And this might actually be a little less work. So what I mean by this is if I have x to the 4 on top and x squared on the bottom, that gives me x squared because I subtract 4 minus 2 and get a 2. If I have y to the 3rd over y to the 1 and I subtract, I get a y squared. And then you can do everything to the 3rd power. So you're kind of simplifying the x's and the y's by using that quotient property first, then raising the whole fraction to the 3rd power. So if I now do 2 to the 3rd power, I get 8. If I do x squared to the 3rd power, I get x to the 6th. Y squared to the 3rd is y to the 6th. And on the bottom, 5 to the 3rd is 125. And as you can see, it's the same answer that we had. Okay. All right, there's 2 U-tries, so please pause the video and do your best to attempt A and B. And when you're ready to check your answers, then go ahead and hit play. All right, let's see how you did on part A. So when I'm dividing the coefficients, 21 and 14, I can divide the top by 7 and get a 3, and the bottom divided by 7 gives me a 2. When I look at the A's, if I subtract 4 minus 1, I get a to the 3rd. If I subtract the exponents with the B's, 6 minus 2 is a 4, so I have b to the 4. And if I have a 7 minus 4, that gives me a c to the 3rd. Notice these are all in the numerator. We will eventually see problems with negative exponents, and if I subtracted and got a negative number, then it would move to the bottom, but we'll talk about that another day. All right, so there's our answer to part A. Part B, now I have a quotient to a power. Okay, so here I just had a power, this is quotient of powers. Here I have a power of a quotient. Okay, so the second property on the back page. So when we take 3 to the 2nd power, we get a 9. A to the 2nd power is just a squared. B cubed to the 2nd is raising a power to a power, so I get b to the 6th. On the bottom, 7 to the 2nd power is 7 squared, 49. C to the 4 to the 2nd is c to the 8 because I multiply 4 and 2 because I'm raising a power to a power. Now notice here we are done. We don't have to do extra work like we did up above in part C there because my bases are all different. This is an A, this is a B, and this is a C. Where here I had 2 X's and 2 Y's and the bases were the same. Okay, so those are your answers to the U-try. Check and see how you did it with those and make any corrections. And if you have any questions, please ask your teacher.